I am Madan Kumar, working as an assistant professor of chemistry in Aero Arts and Science College in Aero. Now, we will discuss about the topic is dye chemistry. Introduction. First, you need to know what dye is. So, dyes are colored organic substances that are used to impart color to textile materials. It remains to be seen where the dye can be applied to the fiber and how it can be used. So, dyes is generally applied in an aqueous solution and may require a modern to improve the fastness of the dye and the fiber. Next, we are going to the see classification of fibers. So, textile fibers are classified according to the sources from which they are obtained. Textile fiber can be classified in two ways. So, first one is natural, second one is man-made. Man-made fibers can be called as synthetic fibers. Natural fibers can be classified into three types. So, first one is vegetable fibers, for example, cotton, linen, jute, gum. Second one is animal fibers, for example, wool and silk. Third one is mineral fibers, for examples, glass, asbestos, and metal. Man-made fibers or synthetic fibers can be divided into two types. So one is semi-synthetic, second one is 100% synthetic. Semi-synthetic means semi-synthesis or partial chemical synthesis. It's a type of chemical synthesis that use chemical compound isolated from natural sources. For example, viscose, acetate, and rayons. What is 100% synthetic fibers? That means without using any natural raw materials. It was prepared only from the chemicals. For examples, nylon and terling. Next, cotton fiber sources. Where do find sources of cotton fibers? Cotton plant is the only sources for the producing cotton. For producing cotton, the cotton seeds are cultivated in a suitable solid at proper weather. After 30 to 50 days, the young plant flower starts. Next, general properties of cotton fiber. The widely used fiber is cotton among the natural fibers. Cotton has the lowest sign and is the least resistant to expose to light, water, etc. Cotton fibers are creamy white. Some variety have a yellowish brown color and some other variety has the bluish tinge. Next, chemical properties. These are attached by acids like HCl, H2SO4, and HNO3. High concentration at high temperature destroys the fiber severely. Dilute solution of acids, if was immediately, cause no harm to the fiber. If not, the cloth loses the strength and crumples to powder. Organic acids like acetic acids do not harm the cotton fibers. Dilute alkalis at room temperature do not show any damage, but if boiled in a solution of caustic soda in the presence of air, cotton turns yellow and loses its strength slightly. The effect of storage of cotton fabric depends on the room used. Moisture will cause mildew to grow on cotton fabrics which are then damaged. Tests have shown that when stored in darkness and low temperature, these fabrics don't show appreciable loss in the strength even after 50 years or more. Next, structure of cotton fibers. Cotton fiber mainly contains number of cellulose molecules in its structure. Cellulose is a straight chain polysaccharide composed by D-glucose units. These units are joined by beta glycosidic linkages between C1 of one glucose unit alpha C4 of the next glucose unit. The molecular weight of cellulose ranges from 50,000 to 5 lakhs. Silk sources. A cocoon sperm by the silkworm, which is a species of caterpillar, is the sources of silk fiber. There are several species of silk producing caterpillars, but the mulberry silkworm called Formex mori produces the best and a greater portion of commercial silk. These mulberry silkworms have been cultivated artificially for many centuries. These are some other varieties of caterpillars which cannot be artificially cultivated are called wild silks. Dussar, Muga, and Eri are some of these wild silks are produced in India. This is life cycle of a silkworm. General properties of silk. Color. It varies from gray to yellow. The color is due to the presence of cerussine. Silk become much whiter, very soft, a luster after decaying. Length. It is the longest natural fiber. The diameter is very thin. The diameter decreases after decaying. Chemical properties. Action of heat. It can be heated to a high temperature without damage. At 110 degrees centigrade, it becomes pale yellow, but 165 degrees centigrade silk disintegrates rapidly. Action of light. Silk is attacked by UV rays of sunlight and is more sensitive to light than any other fiber. Action of acids. Concentrated sulfuric acid, nitric acid, and hydrochloric acids attack more rapidly than wool. When kept in contact with dilute acids for a long time, silk loses its strength to some extent. Man-made fibers. Polyamide fibers. Nylon was the first made organic textile fibers made wholly from raw materials from mineral kingdom. It contains atoms like carbon, water, and nitrogen in its structure. Thus, hexamethyl diamides and adipic acid, both containing 6 carbon atoms molecules, give the nylon 6,6. General properties of nylon 6,6. Nylon is somewhat similar to silk in its appearance and fitness. It has great strength and elasticity. It can be stretched without breaking into 8 to 15% of its original length. Next, chemical properties of nylon 6. It is extremely stable chemically. For example, triclinic solvents, alcohols, aldehydes, ketones, ether, hydrocarbons, chlorinated hydrocarbons, soaps, and synthetic detergents, and H2O, including seawater, don't affect nylon. Dilute acids don't affect it seriously, but it is hydrolyzed by boiling for several hours with a concentrated HCl with adipic acid and hexamethylene. It is also stable towards alkali. For example, treating nylon with a 10% NaOH solution at 85 degree centigrade for 10 hours causes only 5% decreases in strength. It is soluble in phenol, M-cresol, and acetic acid at 25 degree centigrade. Next, polyester fibers. All the polyesters, polyethylene, terephthalene, take is the most important synthetic textile fibers. These are manufactured under different names such as terylene, terene, techron, tergal, tetron, etc. Next, chemical resistance of polyester fiber. Have a high resistance to organic and mineral acids. Strong acids like hydroflurine do not attack the fiber in the cold condition. It is resistance to sulfuric acid is excellent. Even after 3 days of immersion in 5 to 10% of sulfuric acid at 60 degrees centigrade, the fiber does not loses its strength. Polyethylene fibers do not shrink and dissolve in H3SO4, H3PO4. Polyethylene fibers are not stable towards alkaline hydrolysis even though they show some resistance. They can withstand alkali conditions used in mesmerizing or in wet dyeing hot alkaline conditions. Hydrolysis the surface of the polyethylene fibers, filaments, and homogeneously thin than dough. Polyethylene fibers are extremely stable to the action of oxidation and reducing agent. The fibers are stable to NaOCl, H2O2, NaClO2. However, a saturated solution of K2Cr2O7 in H2SO4 at 80 degrees centigrade that decreases the strength of the fiber by 5%. Thank you.